by dt. This is BL. Then what will be the BL of S? Who can tell? Who can tell this? What will be BL of S?
Sir, BL of S. Sir, SL into IL of S minus L into IL. So only sir, SL into IL of S.
Capital IL, right? Capital IL.
Capital L, capital IL.
Yes, right. Minus?
Sir, minus that part will be 0, sir. Because minus capital L, small IL into 0.
Yes, right. Thank you. Thank you. This is actually the Laplace transform of BL. You say S L I L of S minus L small I L of 0 minus. This is the answer actually. So from here you can see that small IL 0 minus is the initial value, initial current of the inductor. Okay, initial current.
Okay, sir.
This is the initial current of the inductor. So interesting thing is that everybody knows that inductor generates the back EMF, right?
Yes, sir. Yes, sir.
So back EMF, this is the back EMF. Minus L, IL of 0 minus. This is the back EMF. Okay.
Okay, sir.
Next is our Laplace of second derivative, second order derivative. We need up to the second order derivative because we have second order equation, right? Second order circuit, RLC series circuit or RLC parallel circuit, they are second order. So in case of second order, so we need to use the second order derivative. That's why we must learn up to this point.
Yes, sir.
Okay. So now we are going to find out what is the Laplace transform of second order derivative function. So from here, we know the Laplace of d by dt f of t. We already know the right Laplace of d by dt f of t.
Yes, sir.
So we are considering that finding Laplace of d by dt f of t. This is the thing, right?
Sir, d square by dt square.
Yes, d square by dt square. Our target to find out the d by dt is d square by dt square f of t, right? Laplace.
Yes.
So
Yes,
we
sir.
have broken this part into d by dt and d by dt f of t. So that's why that we can consider that d by dt f of t equals to g of t.
Okay.
Okay. So that our function becomes
G of T.
capital L of d by dt z of t. Right?
Yes, sir.
So if we do Laplace transform of d by dt g of t, then we found the s g of s minus small g of 0 minus. Isn't it? From the, from the here, the s f of s minus f of 0 minus. This was right. So since here is g, so it will be capital Z and small z. Isn't it?
Yes, sir.
Yes, sir.
Now we are again replacing. What is g of s? G of s is the Laplace of first derivative function
Yes, yes, sir. Divided
d by dt.
DT.
f of t.
F of t. This is the, and this equals to what? This equals to, actually I'm not writing again since it is written on the above of the two lines.
Yes, sir.
So that we have replaced this g of s by this term. Okay, and what is g small z? Small z is the d by dt small f.
Yes, sir.
This is the thing. Now we multiply with the s. So s square f of s minus of 0 minus, and this is the first derivative, so single prime. So the second order derivative function Laplace is s square f of s minus s f of 0 minus minus f prime 0 minus. Okay. Any question? Do you have any question?
No, sir.
No, sir.
So everybody understood, right?
Yes, sir.
Yes, sir.
All right. Now we are going to find out the Laplace transform of integral function. Integration, actually. Integration is the integral function. This is the integration f of t. Similar way we are finding the 0 minus to infinity and integration f of t dt e to the power minus st dt. So here again we have to apply UV formula. So we considered integration f of t dt is a u, and e to the power
Minus
minus
st v.
is the v.
V.
So we apply the u integration of v dt, integration of du, integration of v dt dt. This is the formula. Okay.
Yes, sir.
So
Yes, sir.
first term coming here, the integration f of t dt e to the power minus st divided by minus s, 0 minus to infinity. Right? Because this is,
Yes,
this
sir.
is a simple integration. So that's
Yes, sir.
minus 0 minus to infinity. So d by dt and integration, they are cancel out each other. Okay, integration and differentiation cancel. So f of t, and inner side what will be? 1 over minus s e to the power st. So that thing has been keep here.
Yes, sir.
Right? So now it is coming that if you put integration, so this integration part, uh, limit infinity limit is 0. So minus this minus and the limit minus, limit conversion minus, that becomes plus. Everybody understand, or should I write? I can write for you because you may not understand that what is happening here. Just first part I'm doing, okay, this part, and constant, keep constant this part.
Okay, sir.
So integration f of t infinity dt minus e to the power minus infinity, because infinity multiply with the something also infinity.
Infinity.
Minus
Minus
minus x. What is given here? Integration of f of 0
dt
dt e to the power minus 0.
is 0.
Okay.
Yes, sir.
So this minus and this minus becomes plus. So this term is 0. And this term becomes
Plus.
f of s divided by integration f of t dt by s. This second
Yes.
part comes from here. Because e to the power 0 means 1, right?
Yes,
So
sir.
integration f of t, here t keep constant because here you can see the limit. T equals to 0 minus. So
Sir, but f of s.
f of s will come from here, next part, second part, from second part. Look at this minus become plus, okay?
Yes, sir.
And take it out, f of 1 over s, take it out. Then 0 minus to infinity f of t e to the power minus st dt. What is this? This is capital F of s.
Okay, sir.
Okay.
Okay, sir.
Capital F of s. So capital F of s divided by s plus from there it becomes this integration f of dt s limit 0. And this part is called initial constant value. Okay, if that is the initial constant value given in the problem, then you have to consider this is 0. Then ultimately the integration of Laplace transform integral function is f of s divided by s. Clear, everybody?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Now here we are doing some example. We are doing some example is, this is the given signal. What is the name of this signal?
Sawtooth, sir. Sawtooth wave.
Yes, sawtooth wave. DC sawtooth wave. What is DC sawtooth wave? Is pulsating DC sawtooth wave. Okay. Pulsating sawtooth wave. So function is f of t equals to e by t into t. E by t into t. This is the function of the signal. All right. So as we know, the formula of Laplace transform is 0 minus to infinity f of t to the power minus st dt. So we are considering one cycle. One cycle period is t. So 0 to t, e by t, this is function has been put here. T e to the power minus st dt. From the e by t has been taken out from the limit e by t, then 0 minus to t, T. U has been considered the T. This is
Yes, sir.
U and e to the power, this one is T. So that we again apply the UV formula, UV partial integration formula. Here then we found E by T, T into integration with this one, e to the power minus st, that is minus s e to the power minus st, 0 minus to t, plus second part, this is coming the 1 over s e to the power minus st. So this is 1 over minus s e to the power minus st, and this dt cancel out, finish that part. So again we are doing integration, so that again it is coming to e to the power minus st divided by minus s, 0 minus 2 t. Okay. Everybody clear here this line?
So plus 1 by s.
Plus 1 by s coming because here will be 1 over minus s, right?
Yes, sir.
E to the power
Yes,
minus
sir.
st.
Yes, sir. Yes, sir.
And that minus and this minus becomes plus. Okay?
Yes, sir.
Yes, sir.
After that, we are converting, rearranging the line of that. When you put the limit t e to the power minus s t
Sir.
divided by minus s. Yes, any question?
Sir, I think, sir, in second line, sir, there is a one dt is missing, sir.
dt, one dt missing.
Yes, sir. Yes, sir. Is a bracket, first bracket, sir. Yes, sir. Here, sir.
Oh, yes, one dt is missing here. Yes, here will be one dt. Right, thank you. I have written one more dt. Yes, so I have to revise that slides. Okay, that's why it is written. Check yourself. So here, when we put the limit, then 0, it is 0. When it's 0 t value, then total term becomes 0. So the first term becomes t by e to the power minus st divided by minus s. And second term, it is coming 1 over s square e to the power minus st minus 1, because when 0, then it becomes 1. All right?
Yes,
After
sir.
that, again rearranging, so we found that minus e to the power minus st divided by s minus e by t 1 over s square e to the power minus st minus 1. This is the Laplace transform of sawtooth wave signal. Okay.
Yes, sir.
Yes, sir.
So you can rearrange from there again, whatever you want, it doesn't matter. This is a one cycle sawtooth wave Laplace transform. Any question? Anyone has any question to understand that you could not understand?
No, sir. No question.
So that so far I can guess that you are feeling comfortable with the Laplace transform, right?
Yes, sir.
Yes, sir.
Comparatively easier than Fourier series. Because in case of Fourier series, so if you want to find out the sawtooth wave Fourier series, then you have to do the long calculation, right? A0, AN, you have to find out double. But in
Yes.
case of Laplace transform, just do once, right?
Yes, sir.
Yes, sir.
Very easy. This is another problem example that find out the pulse Laplace transform of pulse function. And that pulse can be in two ways. One is it starts from origin, another one has delay. This T1 is the delay time. Okay, so the first left side figure has no delay, right side figure has delay. So for both cases, we have found the Laplace transform. So can you take a look? If you don't understand, you can ask me. I give you 2 minutes to understand this thing.
Okay, sir.
So, any question?
So what this to do?
And FT1 or
Yeah,
0.
T1.
Over after 1 or 0. Offline.
FT1 equals 0.
Yes, f of t equals to 1. Okay, and rest of that is this has limit 0 to
1.
0. Oh, sorry. T. Let me change. 0 t and t0. This is the for this case is 1 and rest of otherwise 0.
Yes.
Okay. Oh. You can see the figure. If you see the figure, you can draw the function and limit. Okay.
Okay, sir.
No question.
No, sir.
Up to this, no question.
Okay. After this, no question. Very good. That means you are understanding clearly, I hope. So this is your practice. That find out the Laplace transform of rectangular or square wave function signal. Okay. You can see in the lecture sheet it is mentioned. So you have to do yourself and let me know. All right.
Okay, sir.
Yes, sir.
Okay.
Sir, taken, sir, one full square.
Yes.
Full wave,
One
sir.
full, yes. One is square wave.
The full cycle or half cycle?
Full cycle, full cycle. Full cycle. Then here is the final value theorem. In case of final value theorem, everybody understand final means the end or destination, right? Destiny.
Yes, sir.
Sir, no more today, sir.
No, but actually, Jim, you have to understand. No more today, I understand, but the problem is we have to write time constant. So we have to do. And another thing you have to give me more time to make you understand. All right.
Okay, sir.
Okay, sir.
Because we have 48 slides, so we have to finish. That's the target.
So tough, sir.
No tough thing, no tough thing. In the world, there is no tough thing. Hey, who is coming suddenly? So we are going to prove the final value theorem. Final value theorem is the Laplace of d by dt f of t equals to 0 minus to infinity d by dt f of t to the power minus st dt. This is the Laplace transform of first derivative. Our target is to find out the final value theorem. That means time. We always consider the time is the final value of time actually. T is the infinity. T is the infinity. So in that case, what would be the theorem? That final value theorem is the limit s tends to 0 is f of s equals to limit t tends to infinity f of t. The information from here is the f of s is the function of function in the frequency domain or s domain. Okay. So the Laplace domain function will be multiplied with s equals to the function in time domain. Okay, function in time domain, that will be equals when s f of s. Okay. In this case, limit is s tends to 0. That means actually s and t are the correlated things. Okay, correlated things. So in some cases, we apply this kind of final value theorem. We will see some example. Before that, we have to see the proof, how it proved that limit s tends to 0, s f of s equals to limit t tends to infinity f of t. So if we consider this limit s tends to 0, 0 minus, that means this right part here, the limit, this equals to how much? This is s f of s minus f of 0 minus, you already know.
Yes, sir.
So if we consider limit s f of s 0 minus, when you put the limit actually 0, then it becomes limit s f of s minus f of 0 minus, because there is no s with this, that's why it's separated from limit. Again, consider the left side part, that means this part. This part 0 minus to infinity, now limit inside the infinity. Okay. And previous ones, the limit was the outside of the infinity integration.
Integration.
Now is inside the integration limit, right? So e to the power s t dt. So if we consider if we put the value of s, then e to the power minus s to become 1 because 0. Okay. 1. So ultimately, what is coming? 0 minus to infinity d by dt f of t dt. Then we integrate this part. Then we found the f of t 0 minus to infinity. Okay. And putting the value f of infinity minus f of 0 minus. Finish. Now equating both parts, this part and this part, because they are left side and right side are the same thing. So equating both parts. Limit s tends to 0 f of s minus f of 0 minus equals to f of infinity
F infinity
minus f of 0 minus.
0 minus.
This minus f of 0 minus minus f of 0 minus cancel out each other. Then limit s tends to 0 s f of s equals minus this thing. After that, the limit s tends to 0 s f of s equals to limit t tends to infinity f of t. We can write. Okay.
Yes, sir.
Yes, sir.
All right. So now there are example. Okay. I think example we'll do tomorrow. So today up to this, so tonight you have to study all the things what I taught you today.
Yes, sir.
All right.
Yes, sir. Okay, sir. Okay.
Okay. Up to this. So lecture, if anyone has question, you can raise question.